Double tapping refers to connecting two wires to a single terminal on a circuit breaker or other electrical device. It creates a potential safety hazard by overloading the terminal and increasing the risk of electrical fires. Double tapping circuit breakers with two branch circuit wires directly is generally prohibited. However, common trip and handle tie mechanisms allow multiple circuit breakers to be controlled by a single handle, which is permissible. If two branch circuit wires are pigtailed or wire knotted together and then connected to a single wire leading to the circuit breaker, it is not considered a double tap. This is because the pigtail or wire nut creates a single circuit path with a single wire leading to the breaker, eliminating the potential for overloading the terminal. Double tapping is connecting two wires to a single terminal on a circuit breaker or other device. Pigtailing or wire knotting two branch circuit wires together and connecting them to a single wire leading to the circuit breaker is not considered a double tap. Square D and another breaker may allow double tapping for specific applications, but it is generally not recommended. To elaborate further on the concept of double tapping and its distinction from pigtailing, let's delve into the technical aspects and the underlying principles that govern these wiring practices. Firstly, it's crucial to understand the function of a circuit breaker. A circuit breaker is a protective device designed to interrupt the flow of electrical current when it exceeds a predetermined threshold. This threshold is typically determined by the breaker's amperage rating. When an overcurrent condition occurs, such as a short circuit or an overload, the circuit breaker trips, thereby disconnecting the circuit and preventing damage to equipment or the risk of fire. The terminals on a circuit breaker are specifically designed to accommodate a single wire of a specific gauge. This design ensures that the connection is secure and that the current can flow freely without generating excessive heat. When two wires are connected to a single terminal, the contact area between the wires and the terminal is reduced. This reduction in contact area increases the resistance at the connection point, which in turn generates heat. Over time, this heat can cause the terminal to corrode, loosen, or even melt, leading to a dangerous situation. Moreover, double tapping can also compromise the effectiveness of the circuit breaker. If one of the wires connected to the terminal becomes loose, it can create an intermittent connection, which can cause the circuit breaker to trip erratically or fail to trip altogether in the event of an overcurrent. Pigtailing, on the other hand, is a wiring technique that involves joining two or more wires together using a wire connector, such as a wire nut, and then connecting a single wire from the connector to the circuit breaker terminal. This method ensures that only one wire is connected to the terminal, thereby maintaining a secure and reliable connection. The wire connector creates a tight, mechanically sound connection between the wires, which minimizes resistance and prevents overheating. Furthermore, pigtailing allows for easy disconnection and reconnection of individual circuits without disturbing the other circuits connected to the same breaker. The National Electrical Code, or NEC, provides guidelines and regulations for safe wiring practices. While the NEC generally prohibits double tapping, it does permit pigtailing as a safe and acceptable method of connecting multiple wires to a single circuit breaker. However, it's important to note that the NEC also specifies the types of wire connectors that are suitable for use in pigtailing applications. These connectors must be listed and labeled for the intended purpose and must be installed in accordance with the manufacturer's instructions. In addition to the NEC, local electrical codes may also have specific requirements regarding double tapping and pigtailing. It's essential to consult with a qualified electrician or electrical inspector to ensure that your wiring practices comply with all applicable codes and regulations. Now, let's consider the specific case of Square D and other circuit breakers that may be designed for double tapping. Some manufacturers produce circuit breakers that are specifically designed to accommodate two wires on a single terminal. These breakers typically have terminals that are larger and more robust than those found on standard breakers. They are also tested and listed for double tapping by Underwriters Laboratories or other recognized testing laboratories. However, even when using circuit breakers that are designed for double tapping, it's important to follow the manufacturer's instructions carefully and to ensure that the wires are properly sized and installed. Overloading the terminal or using undersized wires can still create a safety hazard, even with a double tap rated breaker. It's also worth noting that double tapping is generally discouraged, even when it's permitted by code or by the manufacturer. Pigtailing is almost always the preferred method of connecting multiple wires to a single circuit breaker, as it provides a more reliable and safer connection. In summary, double tapping involves connecting two wires to a single terminal on a circuit breaker, which is generally prohibited due to the potential for overloading the terminal and increasing the risk of electrical fires. Pigtailing, on the other hand, involves joining two or more wires together using a wire connector and then connecting a single wire from the connector to the circuit breaker terminal. This method is considered a safe and acceptable alternative to double tapping, as it ensures that only one wire is connected to the terminal. While some circuit breakers may be designed for double tapping, it's generally recommended to use pigtailing whenever possible, as it provides a more reliable and safer connection. Always consult with a qualified electrician or electrical inspector to ensure that your wiring practices comply with all applicable codes and regulations. To further clarify, let's explore some additional considerations and best practices related to electrical wiring. Firstly, it's crucial to select the appropriate wire gauge for the circuit. The wire gauge determines the amount of current that the wire can safely carry. Using an undersized wire can cause it to overheat and potentially start a fire. The NEC provides tables that specify the allowable ampacities of different wire gauges based on the type of insulation and the ambient temperature. It's important to consult these tables and to select a wire gauge that is appropriate for the circuit's load. Secondly, it's essential to use the correct type of wire connector for the application. There are various types of wire connectors available, each designed for specific purposes. Wire nuts are commonly used for joining two or more wires together, while terminal blocks are used for making connections to equipment. It's important to select a wire connector that is listed and labeled for the intended use and to install it in accordance with the manufacturer's instructions. Thirdly, it's important to properly tighten all connections. These connections can create resistance and generate heat, which can lead to a fire. Use a torque screwdriver or wrench to tighten screws and terminals to the specified torque value. Over-tightening can also damage the connection, so it's important to follow the manufacturer's instructions carefully. Fourthly, it's crucial to protect wires from physical damage. Wires should be routed in a way that protects them from abrasion, impact, and other hazards. Use conduit or cable trays to protect wires that are exposed to physical damage. Fifthly, it's important to label all circuits clearly. This will make it easier to identify and troubleshoot circuits in the future. Use a permanent marker or label maker to label circuit breakers, junction boxes, and other electrical components. Sixthly, it's essential to follow all applicable codes and regulations. The NEC and local electrical codes provide guidelines for safe wiring practices. It's important to consult these codes and to comply with all applicable requirements. Seventhly, it's crucial to hire a qualified electrician for any electrical work that you are not comfortable performing yourself. Electrical work can be dangerous, and it's important to have it done by someone who is trained and experienced. In addition to these best practices, there are also some common mistakes to avoid when wiring electrical circuits. One common mistake is using the wrong size or type of wire connector. This can lead to loose connections and overheating. Another common mistake is stripping too much insulation from the wires. This can expose the bare wires and create a shock hazard. A further common mistake is running wires through sharp edges or corners without protection. This can damage the insulation and create a short circuit. An additional common mistake is overloading circuits. This can cause the circuit breaker to trip frequently and potentially damage equipment. Also, failing to properly ground electrical systems. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. One more common mistake is neglecting to test circuits after completing the work. Testing ensures that the circuits are wired correctly and that they're functioning properly. Finally, it's always a good idea to document your work. Keep a record of all wiring changes that you make, including the wire sizes, connector types, and circuit breaker ratings. This documentation will be helpful for future troubleshooting and maintenance. In conclusion, Double tapping is a wiring practice that involves connecting two wires to a single terminal on a circuit breaker. This practice is generally prohibited due to the potential for overloading the terminal and increasing the risk of electrical fires. Pigtailing is a safer alternative that involves joining two or more wires together using a Y connector and then connecting a single wire from the connector to the circuit breaker terminal. When performing any electrical work, it's important to follow all applicable codes and regulations and to hire a qualified electrician if you are not comfortable performing the work yourself. By following these guidelines, you can help to ensure the safety and reliability of your electrical system. To reiterate the key differences between double tapping and pigtailing, consider the following points. Double tapping directly attaches two separate wires to a single terminal on the circuit breaker. This concentrates the load and heat onto a single point, potentially exceeding the terminal's capacity and leading to failure. Pigtailing, however, uses a wire connector, such as a wire nut, to join the individual wires together before a single wire extends from the connector to the circuit breaker terminal. This distributes the load and heat more evenly, reducing the risk of overloading the terminal. From a practical standpoint, think of it this way. Imagine trying to force two separate hoses onto a single faucet. It might work temporarily, but the connection is likely to be weak and prone to leaking. Now imagine connecting the two hoses to a Y connector and then attaching a single hose from the Y connector to the faucet. This arrangement is much more secure and reliable as it distributes the water pressure evenly. Pigtailing is analogous to the Y connector, while double tapping is like trying to force two hoses directly onto the faucet. In terms of safety, pigtailing offers several advantages over double tapping. Firstly, it reduces the risk of loose connections. When two wires are double tapped, they can easily become dislodged, especially if the terminal screw is not tightened properly. Loose connections can cause arcing and overheating, which can lead to fires. Secondly, pigtailing provides a more reliable ground connection. A good ground connection is essential for protecting people from electric shock. When two wires are double tapped, the ground connection can be compromised if one of the wires becomes loose or corroded. Thirdly, pigtailing makes it easier to troubleshoot electrical problems. When a circuit is double tapped, it can be difficult to determine which wire is causing the problem. With pigtailing, each circuit is clearly identified, making it easier to isolate and repair faults. Another important consideration is the type of wire used in the circuit. Solid wire is typically used for permanent wiring installations, while stranded wire is used for flexible cords and cables. When pigtailing, it's important to use the correct type of wire connector for the type of wire being used. Some wire connectors are designed for use with solid wire only, while others are designed for use with stranded wire only. Using the wrong type of wire connector can lead to loose connections and overheating. In addition to wire connectors, there are also other types of splicing devices available, such as terminal blocks and insulated splices. Terminal blocks are typically used for making connections to equipment, while insulated splices are used for joining wires in a protected environment. When selecting a splicing device, it's important to consider the application and the environment in which it will be used. For example, if the splicing device will be exposed to moisture or corrosive chemicals, it's important to select a device that is rated for that environment. Finally, it's important to remember that electrical codes and regulations are constantly evolving. It's essential to stay up to date on the latest requirements and to consult with a qualified electrician or electrical inspector if you have any questions. By following these guidelines and best practices, you can help to ensure the safety and reliability of your electrical system. Understanding the nuances of double tapping versus pigtailing is crucial for anyone working with electrical systems. While double tapping might seem like a quick and easy solution, it introduces potential hazards that can compromise the safety and integrity of the electrical installation. Pigtailing, on the other hand, provides a more robust and reliable connection, minimizing the risks associated with loose connections, overheating, and compromised grounding. By adhering to the principles of sound electrical practices and following the guidelines outlined in the NEC, you can ensure that your electrical work is safe, compliant, and built to last. Remember, electrical safety is paramount. Always prioritize safety over convenience and never hesitate to seek the advice of a qualified professional when in doubt.